Hello, this video is on the derivative of a function that equals ax to the power of n. So if we have a function that is ax to the power of n, then the derivative of that is an x to the power of n minus 1. So what happens here is we almost kind of bring the n down and multiply it by our a value if there is one, and then we minus 1 from the power. So what this is finding is the equation of the derivative, so the equation that we can use to find the gradient at any point on our original function. So in the last lesson, when we looked at doing all those different graphs and we graphed the derivative function, that is what we are finding here. We are finding the equation of that derivative graph. And it is a really simple process to do it. I've got lots of examples here to show you all the different ways you may see a function and ways the IB can give you it to really test your knowledge and understanding of working things out. So example, find the derivative of, so the first one, x cubed. We write our derivative notation, so we have f dash x equals. Now with the derivative, what we do is we look at this 3 up the power and we bring that down the front. So it'll be 3. X stays the same, and then we minus 1 from the power, so it'll be 3x squared. If you want, I will put in a little intermediate step here, just to show that we are going to do a minus 1 from the power. You don't need to write that first step in, you can just go straight to the answer. Part B, y equals x to the power of negative 4. So once again, really simple, but there's one common mistake that happens with this. Now, with y, we want to write our derivative, so we can do dy over dx. That's, remember, another way we can write the derivative. And we do a y on the top here because it's a y, it's y equals, and then the x on the bottom, so the dx, and it's an x because we have an x in our equation. Now our process is the same, so we bring the negative 4 down, so we have to bring the negative as well, so it'll be negative 4x, and then we minus 1 from the power. Now the most common mistake here is that people will write negative 4 and then they'll write x now to the power of negative 3. But that's actually adding 1 to the power, so this would need to be negative 5 because negative 4 minus 1 is negative 5. So next we have f of t equals 2 times t to the power of 5. Once again, we just do our derivative notation, so f dash t. Here it doesn't matter that it's a t or an x. We just do the same with the variable. Now we have a 5 at the top, but now we have an a value, 2 at the front. So when we bring that 5 down, we times it by the number in the front, which is a 2, and then we still minus 1 from the power. So then we'll have t to the power of 5 minus 1. Then we can times the 2 and the 5, so we'll have 10t to the power of 4. Part D, y equals 6 divided by x squared. Once again with these, we don't want it to be as a fraction. So the first thing we're going to do in this situation is we're going to change this so it's no longer a fraction, which would be 6 and then x to the power of negative 2. So we just use our index law knowledge there to bring the x squared up, and we just make the power negative. Now we just do the same process as we've done before. Now another notation, if you've just got a letter like y out the front, you can just then write y dash. That also stands for the derivative. Now we've got 6. Is our a value, the constant out the front. We're going to bring that negative 2 power down, so it'll be 6 times negative 2, x, and then minus 1 from the power, which will give us 6 times negative 2, so it'll be negative 12, x to the power of negative 3. And you can leave it like that, or you could put it back to the fraction and make the power positive. E, we have h equals 4j. Now with this one, with the derivative notation here, I'm just going to show you with the d's how this works. So for this one, it would actually then be dh, because it's h equals over dj, because j is a variable in the equation. Now when we have 4j, remember this j would be to a power of 1. And really easily with this one is you can do the process. And if I'll show you this way, so we'd end up with 4 times 1, j to the power of 1 minus 1. But obviously 1 minus 1 is 0, and anything to the power of 0 is 1. So when you just have one single variable like 4j, the derivative of this ends up just being the constant that's out the front, because we end up with the variable to the power of 0. So this here ends up being to the power of 0, and anything to the power of 0 is just 1. f we have y equals 3. So in this equation, I'm just going to do y dash because it's quicker, equals. Now there is no variable, we've just got a 3. Now in this case, the derivative of just a number on its own with no variable is always 0. G, f of x equals 7x minus 2. So now the slight difference here is we have a minus in the middle. This actually doesn't change anything for us derivative-wise, we just do each bit separately. We do the derivative of the 7x, and then we do the derivative of the negative 2. So derivative of 7x, just like part E before, is just 1x, which means that will just go to 7. Then the derivative of minus 2, it's just a constant, it's just a minus 2, which means it goes to 0. So our derivative of this equation would just be 7. H, f of d equals 2x to the power of 4 plus 3x squared plus 4x plus 1. So our derivative of this, once again, we just do each bit separately. So 2x to the power of 4. Bring the 4 down, so it'll be 2 times 4, and then x to the power of 4 minus 1. Then we do the next part plus 3x squared, so 3 times 2, x to the power of 2 minus 1. Plus 4x, we know that just goes to 4, we just get rid of the x, and the 1 just goes to 0, so we don't need to do anything with that. And then from here, we just simplify, so it'll be 8x cubed plus 6x plus 4. When we start having brackets, things like this, we actually have to expand our brackets first and then do our derivative. So we have to think back to our beautiful expanding skills. So if we expand this one, we will get x squared minus ax plus 3x minus 3a. Now, couple of things here that we've got to be aware of is that we have an a and an x. Now with this question, it probably would have been better for the y to be written as f of x, but generally if it's a y, you're using x anyway. Now what in this situation with the a, we actually see the a as just a constant. So we see that as just a number because we're going to do the derivative with respect to x, which means any other letter we have in there, we use it and we see it just like a number, as we would a number. So just imagine it's a 1 or a 2 or something like that. So when we do the derivative of this, we're going to do the derivative of x squared, bring the 2 down and minus 1 from the power, so it'll just be 2x. Now the derivative of ax, so imagine that a is like a 2, if it was 2x, the derivative would just be 2, remember the x just goes, so that will be a. Derivative of 3x would just be 3 because we've only got 1x, so the derivative, the x goes. Then minus 3a, because the a is a constant, it's just a number, this last section, we would see this just as if it was one whole number, and we know the derivative of a number is 0. So the derivative of this part here would be 0, which obviously we don't actually have to write. Just make sure you check which letter you're doing the derivative of, and then any other letter, you just use it like a number. Then the last one, f of x equals x squared minus 6 over 2x. Once again with this, we have to rearrange this first because we do not like fractions. First step would be actually to separate it into 2 fractions. Make that subtraction into 2 fractions rather than one combined. So remember, by doing that with your fractions, you put them both over the denominator. Now from here then, we need to simplify. So x squared over 2x, you can cancel an x, so this would end up just being x on 2. Now the second part, we can't cancel an x because there is only one, but we do have 6 divided by 2, which would be 3. So this one simplifies down to 3 over x. Now from here we want to make it look a bit nicer. So x on 2 we can rewrite as a half x. Then 3 on x, we're going to write that as 3 as the x to the power of negative 1, because remember we don't want the x on the denominator. Now from here we can do the derivative. So f dash x would equal a half x. We've got a single x, which means that just disappears and we'll get left with a half. Minus 3x to the power of negative 1. We'll have the 3 multiplied by the negative 1. And we just minus 1 from the power. And then we can simplify this, so we'll have a half minus 3 times minus 1, which will give us positive 3. And minus 1 here will give us minus 2. And then if we want to write that without a negative power, we can do. And so that is a basic derivative rule. You've seen lots of different situations there as how it can be done and how you can see it, and what you sometimes have to do to equations like expand brackets or separate fractions out, so you're then able to apply the rule. There is no other rule you'll be expected to use in AISL with derivatives, but they do often expect you to do some sort of manipulation like brackets over the fractions to really show your understanding of that part of it before you do the derivative. And you can now go practice.